Hello and welcome to your Mind IDE. And today we're going to talk about resistors. Resistors in series. So what does that mean? Well, usually when you're doing this, you draw out your circuit just like this. So bear with me. Sometimes these resistors that I draw look a little funny. Okay. So what are we looking at here? So this is your voltage source right here, which we're doing resistors in series with a DC voltage. So you can think of this as like a battery. We're going to call this 5 volts. And then resistors are kind of this sawtooth looking thing. That's how you identify them in a circuit. So we'll make this one 1K, or here, just write it out, 1,000 ohms. And this one will be 1,500 ohms. And this right here is a ground. This is positive, this is negative. You usually draw this, this larger side here as your positive, and then this side is your negative. All right, so let's go about solving this. So there's a couple ways that you can do this. Probably the most common way, or the way that they usually teach you first, is you can either do, I think the most common is just to do an equivalent resistance. So what that means is because resistors in series, you just add them up, and then that's your total resistance. So the most important thing is the equation V equals IR when you're dealing with resistors in series, which is voltage equals I is your current and R is your resistance. So if you rearrange this, say if we divide both sides by R, then we get V over R equals I. I'm just going to write this up here. So then you can find your R total. This is a T. And that will be your current. So voltage is 5 volts divided by 1,000 plus 1,500 is 2,500 ohms, which is 5 over 2,500, which is going to be 0.002 amps, or 2 milliamps. And then how we had this equation up here, we just use that again. So then we have voltage, so we want to find the voltage across, we'll call this R1 and this R2. So R, or how you usually do this, is V R1 equals I, which is 2 milliamps. And we multiply that by 1,000 ohms, which is 2, yeah. So 2 volts. And then VR2 is going to be the same, 2 milliamps by 1,500 ohms, which is 3, which makes sense. And why does that make sense? Because according to Kirchhoff, or however you say that, Kirchhoff's voltage law, in this loop, our voltage needs to add up to 0. So we have 5, and then you can look at this as plus, negative, plus. So we're doing 5 volts here as a positive. Or let's go, yeah. So all your voltage sources, So we'll go voltage, that's just our, this is this thing. We'll call V plus, or sorry, minus VR1 minus VR2 should equal 0. 5 volts minus 2 volts minus 3 volts equals 0, which it does. 5 minus 2 is 3. 3 minus 3 is 0. So that works out. The other thing that you might be interested in finding out is the power, which is going to be in watts. And so to do that, there's a couple ways you can do it. So you can go P equals I squared R. So if we do the first one there, P equals 0.002 squared times by 1,000, that equals squared times 1,000 is 0.004 watts, or 4 milliwatts. And then I'm kind of running out of space here. So we know that. So I'm just going to shrink that down and put it up there. All right. So the other way that we can do this is P equals V times I. And if we're doing R2, P equals VR2 times I, which is going to be 3 volts times 0.002 amps. 3 times 0.002 is 0.006 watts, or 6 milliwatts. Milliwatts, which I believe is also correct. So that is your voltage. That's how you find your current. That's how you get your equivalent resistance. Now I'm going to show you another way to do this. No, that's fine. So we'll go like this. So we draw this out again. Need to maybe take up a little less space. Sorry, these sawtooth resistors look pretty terrible. So this is going to be R1, R2, and R3. This is our voltage source. And let's go ahead and make the voltage source 150 volts. R1 will be a 20. So the way you can do this is a lot of times you'll see 20K. And what that means is 20,000 or 20 kilo ohm. So 20,000 ohm or 20K ohm is how you might see that. But I usually just write 20K, and that's usually fine. So then we've got 3K, and we'll have 2K. So we already looked at finding the voltage drop across a resistor using the equivalent resistance. There's actually another way. It's called the voltage drop, the voltage divider rule. So voltage divider rule. Now, it's nothing special. You just go 150 times. So the voltage drop for R1 is R1 plus R2 plus R3, which is 150 volts times 20K over 20K plus 3K plus 2K, which is going to be 20 over 25, which is which is 120. So you can either go 20,000 divided by 25,000, or since these are all going to cancel anyway, yeah, you can either write it as like 20,000 over 25,000, or since that all cancels anyway, you can just write it like that. So 150 times that is 120 volts. 150 times 3 over 25 is 150 times 3 over 25 is 18. And 150 times 2 over 25, 2 over 25 is 12. And does that make sense? Well, let's see. If we go 12 plus 18 plus 120 is 150. So 12 plus 18 plus 150, 120 is 150. So that checks out. So we have all these adding up to 0. And then again, if you want to find the current, you need the equivalent resistance, which is just adding those up. So we could go, so you start V equals IR, divide by R. So then I is V over R. I is equal to 150 volts divided by 25 kiloohms, which is going to be 150 over 25 is 0.006 amps, which again is going to be 6 milliamps. And what else do we need? Well, we could do the power again, the power in each. So power in R1, we know the voltage drop, that's 120. We know the amps, 0.006. So 120 times 0.006 is going to be 0.72. That's 0.72 watts, or 720 milliwatts. Why do I keep doing that? Let's throw this up here. We've got PR2, which is 18 volts times 0.006. 18 times 0.006, which is 0.108 watts, and or 108 milliwatts, sorry, if you prefer that. PR3, so PR3, which we can do the other way if we want, which is I squared R3, which would be 0.006 squared times by 2 k ohms. Oh no, so we're too close to the bottom there. Which is 0.006 squared times 2,000, 0.072 watts. Or 72, this is also 72 milliwatts. And that is it. I think that's all you need to know for resistors in series. Is just the equivalent resistance. With that, you can find the current in the entire loop. The current is going to be the same through the entire loop, so that makes it nice and simple. Because there's only one loop there. The voltage in the loop has to add up to 0. So that's another thing to keep in mind. You can do this voltage divider if you want, if you don't actually need the, say you just want to do a quick voltage divider is really good if you don't really care what the current is. And you just want to find the voltage drop across a particular resistance. So the only other thing I can say is just kind of what to think of. These descriptions aren't going to be exactly accurate, but they work for if you're just starting out, and it's usually what they teach you when you first start out. So you can think of your voltage as essentially the thing that's the driving force. So the more voltage, the more power behind the more driving force you have for your current. Your current, they usually make an analogy to a current like a river, and it's how fast the river is flowing. Yeah, so I think that's about it. If this was helpful, do give the video a like and also consider subscribing. The channel is still very new, so all of your subscriptions really help out a lot. And let me know down in the comments what you'd like to see more of. So I've kind of gone all over the place with this channel so far. We have electrical, we've got general mathematics, I could do some calculus, I could do some coding, just whatever you want to see more of. So let me know down in the comments what you like and what you want to see more of. All right, so thank you so much for watching today. Hope to see you in the next one. And until then, take care.